Hi, I'm Mike Thompson. Let me show you how I built this fairly simple Immersion Wort chiller. Wort is unfermented beer, for those of you not in the know yet. I'm going to use this on my next batch, which will be Beginner Brewer's Blog number 4, I believe, the Hefeweizen, which is finally not going to be a kit. I stumbled a little bit along the way in this. I thought it would be fairly easy, right? It's a coil of copper. But there were a couple stumbling points along the way. So check this out. Make sure you don't make the same mistakes I did. Let me show you how relatively easy this actually was in the end, now that I know how I would do it again. So what I've got here is this tubing I bought off of Amazon, 25 feet of 3/8. I think the wall's a 32nd inch thick. So I've got 25 feet here. I'll measure my pot. It's 10 inches tall and 12 inches in diameter. It's a 4.8 gallon pot. Realistically, I'm only going to put 4 gallons in it. Since I brew extracts and things, I'm only ever boiling about 3 gallons, so I've got 1.8 gallons of headspace at the top. This means that it's about 2 inches deep per gallon. I boil 3 gallons, so my water's never really more than about 6 inches deep. I'm going to make my coil, I think, 8 inches tall, in case I ever want to boil more. And at some point, of course, I'm going to get a bigger pot when I go to all grain, maybe, if I ever do. So for this, I think an 8-inch diameter and an 8-inch tall chiller will work fine. The length of this tube was going to be governed by pi d, which is the circumference of a circle, and x will be my number of wraps. I'm going to keep the height of this chiller less than or equal to 8 inches tall. The total area of the outside of a cylinder is pi d times h. Now, if I let d equal 8 inches here, that gives me about 2 inches per side left on this pot. The OD of my pipe is 3/8, and I want to space it. I don't want the pipe touching, because then that leaves surface contact in between the adjacent coils, and therefore that's less heat transfer. I want as much heat transfer as possible, so I don't want any of my surface area of my copper to be occluded by any other surface of copper. So I want to have a 3/8 space, I think, between it. So that's a 3/4 inch spacing on center. That gives me 25 feet. If we solve this equation here, that's 10.6 wraps. Well, I want the inside and the outside pipes, the inlet and the outlets, need to be really right next to each other. Because as you see here, rather than use a hose clamp or something, I just use some zip ties. And this, by adjusting these, as you see here, allows me to space my coils. And just by adjusting this a little bit, I have a little bit of play left over, but these zip ties are pretty tight now. And so that keeps my coils spaced at about 3/4 inches on center. I tried to bend this first piece here at 90 degrees with my tubing bender, and I wanted this inlet, or I wanted this line on the inside of the coil so that my coil looked nice from the outside. Problem was, as you see here, this would have required a form with a hole all the way up the side in order to make the rest of my coils round, because I don't want to wrap coils over this bump because there will be an obvious bump there. I tried modifying my PVC bending jig in one area, because that won't affect the PVC function in that spot, because I never do 180 degree or 270 degree bends anyway. I tried doing this, but then of course I would have to have something 8 inches tall with a groove all the way up, 3 inches in diameter, and this little lead in here for where the pipe starts to turn. That wouldn't have worked. I started out by straightening one end of my tube 16 inches, according to my design. This tube's malleable enough to do it by hand for large bends. Then I put it in the tubing bender for the first 90. Just like so. That was easy. I wouldn't recommend bending tubing by hand because you might kink it. My PVC bending die was 8 inches in diameter, so I tried using an edge of it as my form to see how it would bend, and it worked okay. So I was off to find a taller form to use to make my coil. I ended up using this piece of 8-inch pipe that I had welded a cap onto. A couple of layers of saran wrap kept my copper clean. Now I would have been able to go with my original design of having the straight piece be on the inside of the coil, but since I had already welded a cap on the end of this pipe, this wouldn't work. So I had to pull the straight portion back outside my coil and start again. A wire staple held the coil in place as I wrapped it around my pipe. It went around easily and was rather fun. Now I only got 10 wraps instead of 11 because of the integer requirement and the slight difference in the pipe size from my ideal 8-inch form. And the onlookers were pleased thus far. Then I straightened the remaining tube at the top of the coil to make the second bend. Then it was time to come off the form so I could get the bender back onto the tubing. This last 90 bend at the top was somewhat tricky, but I made it work by making the bend slightly out of plane and then twisting the tubing into the vertical. And that looks really good. Wow! Now in the end, my tubes didn't come out equal because of the pipe size and integer wrap requirement, but oh well. It's actually okay that this first straight section is on the outside of the coil. Putting it on the inside would have been a manufacturing nightmare and totally not worth it. DFMA all the way. Now some zip ties to hold it where I want it, and yet allow spacing and the height to be adjusted. Now most people hook this up to a garden hose and let the water flow through it. I didn't want to do that, so I cut our old washing machine hoses in half and stuck each half onto the tubing. But I rigged it up to this Harbor Freight drill pump like this. Recirculating icy water saved a ton of water and kept me from having to run a garden hose inside and back out. It was also colder water than I'd get from a hose anyway, and it chilled from 212 to below 110 really quick. I love this thing. It works great. Ultimately, this is going to be a cross-flow chiller, I think, in the future, but for now, it's going to be a great immersion chiller for the next couple batches until I decide to convert it to a cross-flow chiller. But it really wasn't all that difficult. So go ahead and subscribe if you haven't already. I'm Mike Thompson, and thanks for watching. I really appreciate it.